So I didn't want you guys to use Simpson's rule. I want you guys to do the trapezoidal the trap estimation. Okay, so it gives us this data, and it says estimate the distance traveled during the hour. Do you guys remember distance? We got distance, and then if we take the derivative of distance, we get speed or velocity, and if we take the derivative of speed, we get acceleration. Okay, what are the numbers right here being representing? What are they? Are those distance numbers? No. Those are velocity numbers. An airplane's velocity is recorded at 5-minute intervals. Here they are. During a 1 hour period. How many 5s are in a 1 hour period? How many 5 minutes are in a 1 hour period? 12, right? We have 60 minutes divided by 5, 12. Do we have 12 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How come there's 13? Oh, is there one at the beginning? Oh, yeah. So at the beginning of 5 minutes, we have that one. 5 minutes past that one. 5 minutes past that one. 5 minutes past that one. So we have one at the beginning of the hour, one at the end of the hour. So that makes 13. Okay. So with the following miles per hour. Okay, these are all speeds. Now we're supposed to estimate the distance. If we have speeds, how are we supposed to get distance from that? I mean, if we're starting here, how do we get back to here? Antiderivative. Okay, so these numbers that we're given are actually, velocity, or you can call that the derivative graph or f prime, however you want to say it. We're given the numbers for the f prime graph, for the derivative graph. Where are these numbers at? Okay, so we got 0 minutes, 5, 10, 15, 20, 25. I'm just drawing this for visual. All right, we can see that our lowest number is going to be 550, and our highest number, what was it going to be? 640. So 640 and 550. All right, so let's graph all our velocities on here. At 0 minutes, we're at 550. At 5 minutes, we're at 575. Let's say it's right there. At 10 minutes, I guess they didn't give us labels, but I'm going to 0. This is 5. This is 10. There's all your minutes. Okay, at 10 minutes, we're at 600, so I'm going to go up to 600. 15, we're at 580. That's less than 600, so we'll put it right there. At 20 minutes, we got 610, way up there, almost to 640. So there's all your points. Okay, now if we wanted to estimate the distance traveled, we just have to find the area underneath this curve. Hey, that's not a curve, that's just a bunch of dots. You're right. We don't have a defined curve here. We did not define the velocity function. This is our velocity function. You can look at it like it's f prime. If we want to go from speed to distance, what would we have to do? We would have to do the integral of the velocity. There's velocity. I'll put time in there, so there's dt. Cool. And we're going from 0 minutes to 60 minutes. So that's what it would look like. Did you have to write that? No, you did not. You just had to find the area of every trapezoid. What trapezoid? These trapezoids. Here's one right here. Here's another one. Here's another one. Here's another one. Okay, you guys see all my trapezoids? Yes. Oh man, they look so pretty and cute. I love your little illustration, Mr. Patey, except this one's magically fat and this one's magically skinny. They're supposed to be equal, right, Mr. Patey? Shut up. Oh, I shouldn't say that, should I? I need to be more kind and loving, like fathering or motherly, right? So anyways, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, is that right? We have 12 trapezoids to find the areas of. Oh man, we can be annoying and find the area of every single one of them. We can go 1/2, and we can go, what's the height of the first base right here? 550. 550 plus, and what's the height of the next one? That's 575. 575. Yeah, you see this? See this? Yeah, this is not fun. Okay, and what am I multiplying this by?
2.
Oh, snap. This is miles per hour? These are miles per hour. And what are these? These are minutes. Oh, that stinks. I have to change all those to hour units. Ah!
Really hard to do.
Okay, because I was going to put 5 right here, but I was like, that doesn't make sense because that's 5 minutes, and these are hours. So because 5 minutes is a 12th of an hour, we're at, man, I wish I thought of that so I didn't have to write all this stuff. You have 2 over 12, 3 over 12. This is boo, people. Why didn't you say something earlier? You made me write all this stuff.
Yeah, Patrick, why didn't you say something? Why are you looking at me, Ryan?
All right, 7 over 12. Okay, so these are all the things.
Sorry, guys. Sorry to let you out.
Okay. Yeah, thanks a lot, Cassie.
No problem.
Hey, you just sitting there watching us. Oh, they're doing it wrong. They're doing it wrong. They need to be in hour units, not minute units. Okay, but anyways, I guess I didn't need to do that because what is the width of each of these? I'm sorry, not the width. What is the height of each trapezoid? 1/12. Not 5. You crazy foo.
Yeah, he's crazy.
All right, so I'm going to erase this, and I'm going to write 1 over 12. And the next one would also be 1 over 12, wouldn't it?
Yes, sir.
See, 1/2, and then I have to go 575. And what's the other base? 600. It's just the next y value, and then I'm going to have to multiply it by 1 over 12. Oh, dang. Plus. Okay, that's 2. How many do we have to do? A lot.
13.
Okay, so I know I quit. Let's write this a little neater, shall we? I mean, because we have constants in here that we can factor out, let's factor out that 1/2 and that 1 over 12. Since this one has a 1/2 and 1 over 12, this one has a 1/2 and a 1 over 12, and the next one will have a 1/2 and a 1 over 12. So let's take those out. What would I get? 1 over 24, because 2 times 12 is 24. So I have 1 over 24, and then I'm going to have 550 plus, and I'm going to have 2 575s. Right? There's one right here. There's one right here. Wait, why does that say 77? It's supposed to be 75. Okay. And then how many 600s will I have? Okay, I'll have 2 of every number except the first and the last. Very good. So 600, then we have 580. Okay, this is slightly better.
Yeah.
Let's keep going. Let's write the rest of them. Boom! Wow, that stunk. But notice this. The very first side, which is this guy over here, and the very last side, which is this guy right here, only get counted once. They don't get a cool coefficient of 2. So yeah, this would be plugging in a lot of numbers in your calculator. Thanks for that yawn. I really appreciate that. No, you did not. You did not say "oh." No, you did not. You're a liar. Liar. Pants on fire. Okay. So what do you guys get when you do that?